So I am Manuel Will. I'm one of the senior engineers in the Kubernetes distro. So we build RKE2 and K3s. If you're not familiar with it, no worries. I have a couple of slides. And we're going to talk today about deploying AI apps on Kubernetes, best practices and strategies. I have a live demo. And yeah, I'm a bit tight on time, I told you, so I have a hard time. I have a hard stop in 50 minutes. So if you have extra questions, I'll reserve some time for Q&A, but if you have extra questions, this is my email. I'm in Rancher user Slack, so you can reach me and ask extra questions if you have any, or maybe during the weekend you come up with questions. So yeah. So I will, I'm planning to divide the agenda in 3 blocks. One is going to be about AI, Kubernetes, and I'll try to persuade you into thinking that Kubernetes is a great platform for AI applications. Then we'll do a technical dive, depending on how we go on time. I might need to be a bit fast on that one, but in Q&A we can come back. And then the best practices and the demo, I will combine these two. Because I think it's the best way to you understand what's going on. So AI applications, everyone knows about AI, right? Yeah, it's the engine of innovation. It's transforming industries. It's shaping our lives already today. You can find it anywhere, like in the algorithms of the social media or in the latest research done in other areas. Like, for example, I don't know if you're familiar with Nobel Prizes. I really love Nobel Prizes, and most of them this year were about AI, either advancing things related to AI or using AI for advancing other areas like biology. The important thing that I want you to understand is that AI is not a monolith. AI involves a vast array of different applications, and right now, I think the cornerstone is LLMs, which are large language models. And I don't know what will be in the future, but as of today, LLM is the key component of AI. And I would say I created these 2 buckets of applications, either building LLMs or end user apps, LLM apps. For the building LLMs types of apps, it includes the training, digesting massive amounts of data to train the LLMs, also the inference testing to understand how accurate your LLM is. And also something that is becoming very popular right now is the fine-tuning, where you take one of the LLMs from upstream and you feed some information that is normally internal, so that when you ask questions about this internal information, you get more accurate answers. These building LLMs types of applications, they're super resource hungry. They require very complex orchestration tools, and they normally run for days. They're very expensive. And then we have the end user LLM apps, the ones that we are probably more familiar with. We have the assistants like chatbots. We have the content creation that sort of unleash our creativity. You've seen those crazy pictures and videos and social media. Yeah. And then also there are a lot of these apps around analysis that can help you take more kind of efficient decisions that help with efficiency or going faster. So yeah, now that we kind of established the importance of AI, let's explore the different platforms where you could deploy AI. So I came up with this metrics. And these are, let's say, the most popular platforms that where you can deploy AI apps. Serverless, platform as a service, containers as a service, AML platforms, and Kubernetes. And I came up with this sort of different parameters that you can compare them with. Serverless, I'm a very big fan of serverless, things like AWS Lambda. Probably we can reject it very quickly for AI because serverless is super easy to use, very user-friendly. The cost is super cheap, but these serverless platforms are more for applications that kind of triggered by an event, you run it, and after some minutes it dies. AI, as I told you before, AI is supposed to run for a long time, especially when you're building the LLMs, it could run for days. So I think we can reject it. Platform as a service, it's also not the best because for AI, you need an optimizer stack if you want to get good performance, as we will see in the demo. Excuse me. And platform as a service is targeting more sort of web applications. And you don't have a lot of control around the resources. It's also very easy to use. Things are very abstracted, and that also doesn't give you a lot of control on what you see and what you can use. Of course, with the latest advancements in LLMs, for example, last week, the Mistral guy, this is a French AI startup, he announced that their LLMs can run in a laptop. Then we have all this deep sea kind of earthquake. So it seems like LLMs are now consuming less and less resources. So maybe soon, platform as a service could be a place where we could run AI apps. I don't think it is right now, but who knows in the future. But for today, I don't think it's a good idea. And then we have the other three that I think they could be good sweet spots for depending on your application. Container as a service is okay in all the parameters that you can compare. I don't think it's good for building LLMs because it lacks the orchestration capabilities that you need. I don't know if you heard about this term MLOps. You cannot do things like that in container as a service. But perhaps with an end user application type of app, AI app, you could run it there. But again, you're losing control of the resources that you're running. Forget about using the latest and greatest GPUs that are required for some of these AI workloads. Yeah, so maybe as a starting point could be good, but if you start getting more complex, if you also want to customize how you're going to use the AI, if you want to create a more intelligent application around your AI, this is not for you. And then we have AI ML platforms. These are great. These have a very advanced and powerful orchestration tools. They get normally very fast, the latest hardware, but the problem is the cost, and they lock you in. Well, you can imagine, we're now sort of starting with AI, so there are a lot of these platforms right now. At some point, there will be a consolidation, and as you need to invest in their API time, effort, and training, and you need to train everyone around, it might be that today you're here, and a couple of years, everyone is there, and you're still here, and that transition will be painful. So that's one of the advantages of Kubernetes. It's open source. There's a lot of companies contributing to it, so you're not locked in. Yeah, you can move your application from one Kubernetes distro to another, and it will work. When you're using Kubernetes, you can optimize your stack, as I will tell you in one slide. It also has very good orchestration capabilities, and if it's not good enough for you, it's very easy to extend those. Kubernetes allows you, it's a very powerful platform that allows you to customize things, and yeah. I'm going to talk about the advantage of Kubernetes in one slide. But what I want here to highlight is that probably the worst thing of Kubernetes is that it's complex. It has a steep learning curve. It will take you months or years to learn all the details about Kubernetes. Yeah, so probably the smartest thing to do is like partner with a company that knows about Kubernetes or has Kubernetes products. Hopefully us, hopefully SUSE. And yeah, this is a bit like Linux, I would say. So if you compare an iPad or an Android platform, an Android mobile phone with Linux, right? My kid probably is able to use the iPad. If I put my kid in front of a Linux terminal, he will destroy things. And so Linux is complicated, but Linux is very powerful. We're building our whole 5G network on Linux. You cannot do that with an iPad. So this is a bit the same. Kubernetes is complicated if you compare it to PaaS or serverless, but it has so many things that you can switch, so many knobs you can turn that, yeah, it allows you to build very powerful applications. So, why I think, what are the benefits of Kubernetes? Does anyone here not know about Kubernetes? Depends how, okay, make it go very fast, and then save time for the demo. Right, so Kubernetes is very flexible and customizable. These are some of the advantages. There are more, but for me, these are the best ones. It's easy to make it reproducible and to collaborate between teams because, yeah, you feed Kubernetes with some configuration, some manifest that you can share with other teams, and in the end, you get always the same result. This is good for GitOps if you know about the software development philosophies. It's easy to optimize the stack. Normally, when you deploy Kubernetes, you have control on your Linux host OS and on Kubernetes, and then you can optimize those, or you can configure those in a way that provides you the best characteristics that you need. I have people here in the audience from the edge. They are very like Alberto was presenting the other day about how to get very low latency by doing some tuning in the OS. Kubernetes as well, you can pin CPUs, you can use NUMA types of architectures to kind of boost your performance. So you can do all these things that will give you very good numbers for your application. And AI apps are very performance dependent, as we will see in my demo. Kubernetes, from the beginning, it was designed to scale. It's very good at scalability and resource management as well. You can have a very good resource control. And it also has very good advanced orchestration capabilities that are required for example, when you want to build LLMs for all these complex pipelines that you need to deploy. It's also robust and adaptable. There are a ton of different monitoring and observability tools, from super easy and simple to use, like kubectl top, to super advanced, like SUSE observability. It's resilient and reliable. Again, from the beginning, it was developed with very good self-healing capabilities. So, yeah, it can recover from disasters and from various things that you can do to it. So you can get great high availability on your applications. It's flexible and portable. That's what open source gives you, of course. You can just move your application from one Kubernetes distro to another, and it should work. And one of the things that I really love about Kubernetes, it has a huge and rich and thriving ecosystem. There are a lot of applications around. There are a lot of projects that are working with Kubernetes, a lot of companies working with it, with developers, not just blah, blah, blah people. It's really developers creating this project that you can use. They're solving a lot of very interesting use cases. And some of those projects are in production environments, and they're open source. You can just reuse them, right? And just to give you a glimpse, these are, and sorry because I don't know if you could see, but these are all the projects around AI that you can find in the CNCF. All these projects you could download and use them right away. You have some about processing all these massive amounts of data that you need for LLMs. Some provide you some extra functionality in orchestration, like Volcano. Some provide you some security, like Hivernal. They had a booth. I don't know if you saw them with this green T-shirt. Yeah. So all of these are targeting specific use cases of AI or specific phases in the LLM building, and yeah, you can use them. They're for free. So yeah, it's a great ecosystem. Now, moving on into the Kubernetes distribution, my team, where I work, right? We're building two different Kubernetes distributions for two different use cases. We have RKE2, we call it our highly secure and configurable Kubernetes distribution. It's a Kubernetes distribution that is hardened. That means that we are downloading the source code of Kubernetes, of all the different components, and there we are building it using best practices and using some crypto libraries that will provide us compliancy with FIPS. So we are building stateless and binaries and compliant with FIPS, so that's why we call it. It's hardened. It's versatile because, well, most of you have worked with Kubernetes. When you deploy Kubernetes, you need to take certain decisions, like your CNI plugin. And RKE2, we don't tell you what you need to use. You have different options, and you can choose between them. Also for the ingress, also for the data store. So yeah, there are different options that you can choose. Make your choice, right? That's what the keynote said. And then Solid. In other slides, you might have seen enterprise ready or something like that. I don't want to put that because it seems like K3s is not, which is super enterprise ready as well. I say solid because RKE2, so my manager is obsessed with CVEs, and I would say that I think that in the last 3 or 4 releases, we've always released with 0 major or critical CVEs. Of course, after a couple of days, you get some. But yeah, then we are also complying with Salsa 3 for yeah, that it's one certificate that is very good, that tells you that you're building things correctly. What else? We are compliant with CIS profiles that, yeah, they give you a very good, and then you pass the benchmark. They give you very good recommendations about how to deploy securely your Kubernetes. We comply with them, and so on and so forth. There are other stuff. So it's a very solid and secure distribution. And then we're open. This is open source. You can download it and use it. And yeah, I invite you to do it and give us feedback. This is, of course, the use cases you could guess. It's for secure environments, enterprise environments, highly regulated industries. I wrote it in enhanced capabilities, kind of reflect what I told you already, that you can deploy many different option configuration projects, things like Multus, SRIOV, that provide you some enhanced capabilities. And we also support Windows in RKE2, so Windows nodes. And then we have K3s, which is, I think, the most popular Kubernetes distribution. It's lightweight and opinionated. It's simple. K3s, in the end, it's just a binary that when you execute it in seconds, you get your Kubernetes distribution. That binary includes, we are embedding in that binary the different tools that you will need from Linux. So it can run in super bare bones types of operating systems. So it can run almost anywhere. It's lean. So this binary, I think right now it's 68 or 70 megabytes. And when you run it, the consumption of memory and CPU is super low. And it's optimized or opinionated. So remember, I told you that you need to take some decisions on components that you're going to run. In RKE2, we allow you to do that, allow you for you to pick and choose. In K3s, we are doing that. We're taking that decision for you. You can, of course, disable that. But we're taking the decision with the goal in mind of deploying, of having a Kubernetes distribution that is super low, that consumes very low resources and is super fast. So, for example, for the CNI plugin, we use Flannel. I'm a maintainer of Flannel. And Flannel does not give you the feature set that other CNI plugins provide you, by far. But in all the benchmarks, is the best CNI for the same amount of throughput. You get the least amount of resource consumption. I can share benchmarks with you that kind of unbiased organizations did. Yeah, and it's open. This is even more open than RKE2 because K3s was donated to the CNCF. But again, you can download it and use it for free. And yeah, the ideal use cases, as you could guess, is edge, IoT, any type of resource-constrained environments. And we've seen a massive adoption of K3s in CI/CD pipelines, organizations, industries, companies that are developing cloud-native applications. They use K3s to test it because it's so small and it runs so fast that, yeah, it's perfect for CI. All right. I don't know how we're doing on time. Okay. Yeah, the marketing guys didn't want me to show this slide. So they said, oh, it's too deep. But, you know, after some days talking to people like Eric, for example, like I know people here like technology, and I said, why not? So I'm going to do a small and fast technical deep dive on GPUs, how we are exposing them to the pods. As you are familiar with GPUs, right? They're super important for AI applications because they have all this parallel processing, high bandwidth memory, specialized cores for deep learning. And if we want to expose the GPU to the AI app, the whole stack needs to be ready, needs to be well configured to do that. Yeah. So this is important to know how to do it in the right way. So for example, in the host OS, we have all these components that need to be working properly. We have, of course, the kernel driver. And here, this is the example of NVIDIA. We have the kernel driver that when you load it, it will create this virtual file system, typical way of interacting with kernel drivers. And you have the chart device, the NVIDIA Cuttle, that you can communicate with the kernel driver. This is pretty dry. You don't normally interact with it. There's normally a library, in this case, NVIDIA ML, and through that library, you communicate with the driver and with the GPU. This is the library that tools such as NVIDIA SMI and other type of tools that allow you to debug interact with, and also how Kubernetes interacts with the GPU. And yeah, I don't want to go into a lot of details, but that's how it is. And then in Kubernetes, excuse me, let me drink a bit. This is probably now the first best practice. Exposing the GPU to the pod needs a lot of configurations in Kubernetes. And if you have advanced features like NVIDIA has, you also need some extras. So best practices, please follow their documentation and deploy the operator. NVIDIA, AMD, Intel, I don't know about the others, but they all come with an operator that sort of orchestrates the deployment of all these different components that you need to run GPUs effectively in your pods and correctly. I've seen some users, a couple of customers that they deploy these things by themselves and separately. It might work, but then it's a pain to upgrade. They run into problems, so please use the operator, which is what their documentation is saying. Anyway, the GPU operator of NVIDIA deploys different things, but the most important ones, I would say, are the NFD and the device plugin. If you're not familiar, well, kubeAPI is the API to access Kubernetes. It constantly talks to the database, normally etcd. And kubelet, which is the Kubernetes component running in each of the nodes. Kubelet is sort of controlling the lifecycle management of the pods. It talks to the container runtime, which is the one that creates, removes the pods, etc. So the key component here, in my opinion, is the device plugin. The device plugin runs in each of the nodes. And using the library that I was telling you about before, it's able to discover your hardware, in this case the GPUs, and it collects all this information that is useful. It tells that information to kubelet, and then kubelet talks to kubeAPI and tells them, in this node, you have a GPU. I think I'm missing an arrow there from the container runtime and device plugin, because it also, when you create a pod that requests the GPU, the device plugin is the component that will tell all the information, PCI, address, and so on, to the container runtime, so it knows how to plug the GPU into the pod. So this is a very important component. The NFD is pretty interesting too, pretty important. It also collects information about the GPU and puts it as labels, normally in the node. So you can add some extra parameters to your orchestration and to how Kubernetes schedules the pods. And yeah, there are some other components, but they're not that important. Like the GCM exporter, this allows, there are some others that allow some extra features from NVIDIA. I don't want to go into details because I want to go to the demo. All right, so this is the demo. I have 3 SLES15 SP5 VMs in AWS. One of them uses NVIDIA Tesla T60 GPU. I'm using Rancher Prime. I'm using RKE2. I'm deploying an NVIDIA operator, and I have Ollama and WebUI. For the ones that don't know, Ollama is a type of application, kind of cloud-native application that allows you to consume LLMs very easily for chatbot type of interactions. But we will need to go to the terminal, and that's probably a bit too dry for a demo. So I deployed also WebUI that interacts with Ollama so that it looks like we're talking to kind of ChatGPT, sort of. So what I did was I deployed 2 Olamas, one following the best practices that I will tell you about in the next slides, and one not following the best practices. And hopefully, if it works, you will see the big difference. Okay. I have a problem, though, that the cache, if I don't use the LLM often, like after some hours, the cache gets removed. So it takes like 2 minutes to load. So you know what we're going to do? I'm going to start loading, and then I can start, while it loads, I will tell you about the security best practices. Give me a sec. I'm mirroring it so that you see that I'm not doing anything. I'm just going to run, and while it loads into the cache, I'll tell you the security best practices. So, of course, deploy RKE2. As I was explaining before, almost no CVEs. Everything is hardened. So, yeah, it's great for security. Then the second one, deploy your applications using application collection. I don't know if you were yesterday in the Cloud Native roadmap with David. He was explaining about this, probably in the booth, if you were talking about application collection. Just for a minute, think about all these applications that I showed you before in the CNCF, these AI applications. Some of these applications are releasing monthly, and they put their images in Docker Hub. Some of them, they put their images in GHCR. Some of them, they just release the code. Some of them, they don't care about CVEs. They want to, push features, and that's it. You don't know how good the testing of these applications is. So it's sort of, you have this heterogeneity. Also, David explained yesterday, there are some applications that deploy different pods. All of these pods running images that have different operating systems. So it's a bit of a mess. So what the colleagues of application collection are doing is they take the source code of all these projects. Not all, I think the count is on 72 now. They build it using best practices, so you remove a lot of the CVEs. They test the code, so you are sure that what you deploy should work. They put it in the same registry, which is a SUSE registry, so it's sort of reliable that what you get is what you should get. And they also keep track of CVEs. So there is a nice search bar that you can type a CVE, and it will tell you, okay, for example, in Olama application, since when that CVE got remediated, got fixed. And so it's a good way to deploy applications in a reliable kind of, you could rely that. So yeah, I think it's a good way to deploy applications. I'm using it in my Rancher Prime. I'll show you in a second. Once we touch on the do not expose all your GPUs and do not allow all GPU capabilities. This is sort of following the principle of least privilege, so only provide access to certain capabilities if the pod actually needs them. And now jumping into my Rancher Prime. And I'm deploying with RKE2. Using application collection is pretty easy. Have it here. And yeah, you get all these applications here that you can deploy securely. And yeah, what I wanted to show you now, so we have here there's 2 Olama, and Olama Slow. And if we check on Olama, about what I was just explaining to you, in NVIDIA, you can specify this environment variable where you tell it, okay, how many GPUs should be exposed to this pod? In this case, I'm only exposing 1, and that's what you should do. And also, what type of capabilities are you exposing? You can expose compute, utility, graphics, and video. For AI types of applications, you only need compute and utility. So let's just expose those. And I think 100% of all the tutorials I saw doing things around this, they just type here all, and here again all. Yeah, you shouldn't do that, because that creates more surface of attack, right? What else? Right, network policies and RBAC. Of course, GPUs are very expensive to use, so be mindful on what type of person can create these pods that use the GPU resources, right? So you can, normally the best practice is what would tell is that you create different roles in Kubernetes and you give the kubeconfig only to the people that, so the roles that allow you to do a lot of stuff, you only give them to the people that are, only one people, the admin, right? Also, remember these pipelines to build the LLMs, they require days to finish, so it's good that you don't give, maybe there's a mistake, somebody deletes a pod and the work that was done for days is lost, somebody will get angry, so please create good RBAC there so that only the people that you want to use these pods can use it. Also network policies, so that you isolate that pod and not all the pods can interact with it. It's also best practice. And for sure, keep upgrading. You will reuse a lot of the CVEs. Yeah. Let me see if it already loaded. It did. Okay. And let me now load the other one, and then we can do the full demo. Okay. Right. So what we're going to do, this is Web UI. I'm going to connect to the Olama where I'm following the best practices that I'm starting to share with you. All right, so I have two services, Olama and Olama Slow. Right now we're connecting to Olama, perfect. We're just gonna say, show me a code snippet, for example. And hopefully, if it works, So you see it's replying as, this is probably what you're familiar with, right? When you interact with ChatGPT, it goes fast. It answers what you were asking. Now, if we connect to the Olama that is not following my best practices, and again, we just touched on the security ones. Okay. Now we're connected to the bad one. I didn't check if it had loaded. Maybe it didn't load the look. Look at the performance. It's really bad. It's very slow. So you can follow best practices, read the documentation, because otherwise you're gonna get this type of performance, which is really bad. And it's only me. If there were more people trying to interact with it, it will be even worse. These are kind of two extreme scenarios because I'm applying no best practice on this one, so the performance is worse. It could be improved, but yeah. So moving on to the slides, now moving into the sort of more performance-related parameters, resource consumption and bugs. For resource consumption, one of the best practices is that in the nodes where you have GPUs, try to, if it's possible, reserve those nodes only for AI types for AI pods. Even if, of course, you can specify what pods can use the GPU. Memory and CPU are also, these AI apps consume a lot of memory and CPUs and cores. So try to avoid the type of contention scenarios. So if you could reserve these nodes only for AI, that would be great. Partition the GPU if possible. I cannot show it to you because the GPU I'm using is not super expensive and it doesn't allow to do that. But there are ways to partition the GPU, and you create like sort of virtual GPUs out of one physical GPU, sort of SRIOV, if you know what that is. There's also the time slicing way of partitioning the GPU. That's also possible. What else? Use resource quotas. Okay, so if you can't reserve one node or several nodes with GPUs for your AI apps, then I would recommend you to use the resource quotas to limit the resource consumption per namespace. This is something I am doing in the good Olama. You will see it here. I'm requesting one NVIDIA GPU, of course, 2 gigs of memory, 1 CPU, and I give a limit of up to 2 CPUs, 3 gigs of memory, and yeah, I only have 1 GPU. If the pod goes over those limits, then it will be the CPU will be throttled. This is using C groups in the Linux. And if it goes over the memory, there will be some out of memory type of processes going on. Around this, I learned a very good lesson on Monday. This guy from Brazil showed this Goldilocks application, which is really cool because it's it's tracking what's the consumption of your pods, and after some time it tells you, you reserve this amount of memory, you're not using it, so please reduce it. So for example, this is one application on CNCF that could be useful for this. Oh, and by the way, I forgot that if you want to reserve your nodes for AI pods, the best way to do it is through taints. Now that I'm reading this. Taints you put in the node, and these are kind of blockers for pods, and only the pods that tolerate those taints can be deployed in those nodes. I'm doing that with this application as well. Give me a sec, I can show you. Must be here. Here it is, the toleration. So this pod can deploy in that node, but the rest cannot do it. And I have it, the taint, I think you can see it here. Taints. So I created that taint, and that workload can tolerate the taint. Let me go back to the YAML because I think I want to show you one extra thing. Right, the last deploy an observability solution, of course, very, very useful. Things like SUSE observability, you saw it in the demo yesterday, the Palooza demo. This is very useful when you're using expensive hardware resources like GPUs. Yeah, being on top of how it is being utilized is very important. And finally, this is something that's happening to me very often. Use provisioning tools to deploy your GPU-capable instances in the cloud. Things like Terraform, Ansible, things like that are very useful. If you use ClickOps, you might forget stuff in the cloud, and then your boss will scream at you because it's super expensive. When you use things like Terraform, you just execute one destroy command, and then everything is removed. Okay, and finally, reduce bugs and complexity. I don't know how we're doing on time. Okay, it's good. Yeah, use runtime class name. This is a pain. So these operators, especially NVIDIA, they require their own runtime for reasons. I understand why they need it. The problem is that if you deploy the NVIDIA operator how it is without doing any changes, it replaces your default container runtime, and it overwrites your configuration of containerd. In both RKE2 and K3s, we are using containerd as our container runtime, and if you deploy the operator as it is, yeah, it will be replaced. That's not good. That's not good, and sometimes we have users complaining, hey, this is not working, and then we realize, oh, but you're using NVIDIA container runtime for pods that have nothing to do with AI. So there is this concept of runtime class name, which is better. So you leave your containerd as the default runtime, and then for the pods where you need another container, you just specify that in the manifest. I'll show you. I'm doing that, and I'm not doing that in the Olama slow. So wait here. So in my deployment, even though I'm using NVIDIA operator, I kept containerd as my default runtime, and for this specific pod where I'm using their GPU, I'm using runtime class name NVIDIA. There are other runtimes like WASM, for example, is pretty popular. People deploying WASM types of application in Kubernetes. But yeah, you don't want WASM to be your runtime for the whole cluster. So use this, use it like that. Follow our documentation. Because otherwise you might get in trouble. Some of these things will hopefully disappear when people move to Containerd 2.0. It was released in November. Because now in Containerd 2.0, things like CDI, these are mechanisms that standardize how Containerd talks to the hardware. In 1.x, we didn't have that, and that's why NVIDIA had to do all these tricks. In 2.0, this is gone, and hopefully all these different GPU vendors will start using the established standard ways of interacting with hardware. Third point, prefer OS provider kernel drivers. This is another hack that I don't like. I don't know if anyone from NVIDIA is here. You have two ways to remember the NVIDIA.co, the KO that you saw there, but it's the same for AMD. You need that kernel driver, of course. There are two ways to get that kernel driver. Either the distro will give it to you, which is the typical way, and this is what I would recommend, or these operators can inject the driver into your kernel. I was talking yesterday to the PM of SUSE AI, and he was telling me that in most of the distros, if you do that, you void your support. So don't do that. Take the kernel driver from the distro. It's probably, and I'm 99% sure that it's better tested, because at least in SLES, we are testing things for days. I don't know how NVIDIA is testing this. So in AMD, for example, AMD operator, the default is that you provide your kernel, the distro provides the kernel. In NVIDIA, is not the default. So please change that. And NVIDIA is smart enough to these tools that they provide to detect it, and if it's there, then they don't do anything with your kernel. But yeah. And finally, keep all components up to date. This resonates. It's aligned with what I told you in the previous slide. It was more about CVEs. This is more about bugs. So yeah, if you keep your components up to date, you will fix a lot of bugs. Yeah, so I only have conclusions, but repeating. Kubernetes, I think it's a great platform for AI apps. RKE2 and K3s are best-in-kind Kubernetes distributions that we are building, and we're very proud. And a whole stack is needed if you want to expose the GPU to the pod. And please follow best practices. Please follow our documentation, and run your applications in a secure way. Optimize the resource consumption of these apps, or you will see the performance issues that I demoed, and minimize the complexity to reduce the risks of bugs. That's it. Thank you.